Hi, today I want to talk to you about a topic that I've been kind of meaning to talk to you for a while. This is on unit testing. So this is sort of a more formal approach to testing than we've been doing in our own assignments with little tests in main and so on. All right, so testing is a big area in software development. In fact, there's often either a role or a group devoted to this topic, QA or quality assurance. And the topic we're talking about, unit tests, is just one small part of the overall area of testing. For example, you can do like performance testing. Your code may be correct, but it might not hit the kind of performance needed to be a successful product. For example, you can think of a video game where the update rate, the frame rate isn't fast enough to make it look smooth. Security testing, where you have people try to exploit various holes in the user interface or something to see if they can get in there and cause problems. Accessibility testing, basically evaluate how well software works for different groups. Anyways, a lot is integration testing, see how components work together. Stress testing, where you try to sort of hit it with maximum load and see if things start to fall apart. Anyway, those are just a few examples. I have a link down here to a little more comprehensive list of tests, testing strategies, but that's just one list as well. So anyway, testing is a whole interesting area. Some people really like it. And of course, it's very important for the overall success of a software product to make sure it's well tested and hopefully mostly free of errors and bugs. So unit tests, what we're talking about today, are basically small tests designed to test small chunks of code. Those chunks of code are usually methods, for example. And in fact, that's one reason that it's nice to break up your code into different methods, is that you can test each part individually, as opposed to a big chunk of code where it's sort of hard to figure out where the problem may be. So unit tests are a real fundamental part of software development these days. You're expected to write tests for your code as you go, and they're a good check to make sure that at least it matches some sense of correctness. So one issue with unit tests is that it's not going to reveal bugs in the code directly. All it reveals are mismatches between values that you expect from a computation and values that you get from a computation. So if you're trying to sum up numbers in an array, you might test it and see that the answer is, add up 1, 2, 3, 4, 5, and see that the answer is not correct. That does not tell you directly where the issue is or how to fix it. It just tells you that something is going wrong in that piece of code. Now again, if you do it on small chunks of code, it makes it pretty easy to figure out where you should look for that error, and it kind of focuses your search for fixing it. And another issue is that you can't prove correctness, right? You can only prove that for some hopefully generalizable and reasonable set of input data that we get correct results back, but that of course does not guarantee that it's correct for all inputs. And in some ways, it's your job as a tester to try to make sure that you are doing things that sort of cover enough cases that you have some confidence in the overall result. So there's a certain skill in making tests, as you sort of found out for the homeworks, right? When you're writing your tests, it's not enough just to check that it does one answer back. You have to kind of think carefully about what set of inputs and answers you're looking for to kind of show that you think the overall code is correct. Okay, so our again, these unit tests that we're going to write are basically a formalization of the testing we've done in main, where we asked you to say what was being tested, what values were going in, what values came out. One difference with unit tests is that it will compare those expected and output values and see if they're the same, so it can make some determination whether it matches. So there's there's no one way to do unit testing. There are packages that support unit testing, and one of the most popular is called JUnit testing, and Eclipse has integration with JUnit testing, so you can do it pretty easily. And the basic idea in JUnit testing is you have a test class, so you have a separate file, and the class is named usually some, like if you're trying to test like a class X, like let's see, what are the, well, like dynamic array, for example, you would write a test class dynamic array test. And in the test class, there's methods that call the code in the class you're testing, and those test methods basically create either a pass or a fail. And your job is to set up a bunch of tests such that and fix the code such that all the tests pass. So you always want to make sure you structure things that a correct result means that it passes the test. Like, you know, if you have a method that returns true or false, you don't try to make a test that produces a fail for false, and you say, oh, that was good, I want it to be false, right? You want to check that it is false, so it would be a pass, right? So you want to have pass, 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 pass. Otherwise, you have to interpret the test and say, well, I meant to be that a fail, I meant that to be a fail, and that's very confusing. So you want everything to be a pass. Okay, so how do we do it? Here is the dynamic array 2 class in my homework folder. I actually happen to have a test class already in there. That's basically the start of the autograder. The autograder uses JUnit tests. So I'm going to make another JUnit test here. So I'm going to right click on it. I'm going to say a new JUnit test case. There's different options here. This JUnit Jupyter is really JUnit 5, the next one up from JUnit 4, and kind of the most current JUnit tests. And it's going to be added to the package, so it's going to live in the same folder as the actual code that you're testing. And here it added a test on it, so it's dynamic array 2 test, and because I already have one, it added a 2 on the end for me. And there's a bunch of stuff you can do, you know, to kind of get things going, but we're not going to do that. And I'm going to hit finish. Now, if you do this the first time, it's going to ask you to add JUnit 5 to the build path, and you should just accept that. And I will say that if you try to make a test case without using the wizard, and it's the first test case in that project, like let's say you copy in some test examples from somewhere else, you'll have to go in by hand add this JUnit 5 to the build path, and you have to Google how to do that. All right? Or the other easy way is to actually just like start it off with a wizard and then replace the tests with these tests that you want to use from somewhere else. Okay, so here is an example test file. We don't need to look at the package stuff anymore. I guess I'll even shrink it up all the way. So it lives in the same package. It imports a bunch of stuff for you that, again, you're not really all that worried about unless for some reason you're trying to create that by hand. I wouldn't really know how to, find this set of imports myself very easily. It lives in its own class. So again, there's a bunch of methods in here that the test process is going to know how to call. There is this annotation. We haven't seen annotations before, but we'll see a few more of those as we go along. And it basically tells Java that this is a particular kind of thing going on here. In particular, this one says, hey, this thing can be run as a test. Okay, so this @test is an annotation. And here's a method. Just like any other method, it has sort of a this is just a default kind of name, test. We don't pass information into it. Basically, all the stuff happens inside the method body. And in this case, this thing is designed to produce a fail case. It's not, they don't want you running this test really, right? So they want it to fail every time. So there's a specific command, fail, that says this test fails. It's sort of funny to have a test that fails all the time, but maybe you have some code that returns if it's successful before it hits the fail, and so if it doesn't hit the fail, it's good. If I run this, it will tell you all the tests it runs, and then here it says ran 1 out of 1, and there's 1 failure, and it gives you this red bar that there was a failure. So this set of tests did not pass, but it's not designed to pass. It's designed to start off and just be some basic structure here. Okay, so let's write a real test for the dynamic array 2 class. Typically you're going to have multiple methods, each testing some small idea or some specific method. And you need to give them, methods have to have different names, right? So you want to give it, often you give it a name that means something about what's being tested. So I'm going to say test starting size. So, the dynamic array 2 has a size, and I want to see if that thing starts off how I expect. I'm going to get rid of this thing here. So again, in a method, typically as part of a test, you set up whatever data you're planning on using for the test. So in this particular case, I'm going to make a dynamic array 2 object. And then I want to test it. So here, what do I want to test? I want to test that when I make a new dynamic array 2 object, that it starts off with a size of 0. Because that's what it's supposed to be doing. So how do I do that? I use what's called an assert. An assert says, I'm going to check if this following information is true. And in this case, I'm going to check that two things are equal. Excuse me, let me get a little more. So I'm going to assert that two things are equal. And the structure is that you have an expected value. So I'm going to check that the DA2 size, when it first is built, is 0. Let's start with that. All right, so it's sort of maybe a little backwards how you want to say. You sort of want to say, oh, here's the size, and is it 0? Instead, you're going to say, here's the thing, the value that's expected. Here's the computed value. Often that is just a call to a method. It could be an expression of some kind. And I'm going to assert that these two are the same. So if I run my test, it says I ran 1 out of 1. I got 0 failures. It's all green, so it's good. And there's really you don't have to look at it. As long as that's all green, you don't really care about anything else. It's only when things go bad that you have trouble. Okay, so let's try to make it fail. Let's say I was looking at that backing store and I thought, okay, maybe the starting size is 8. Remember, size is really the virtual array length. And so if I was confused and I was doing this like returning the wrong thing, and I ran it, it would say, okay, 1 failure, got the red stuff. We should worry about this test starting size, and maybe we should make this a little bit bigger here. Okay, it says assertion failed, expected 8, but was 0. All right. And again, now we have this notation again, like we're sort of like the autograder. Now we have the angle brackets kind of showing the different, demark the different values. So here we have an 8, and here we have a 0, and it tells you where it did it, right? Test starting size. Now again, it's not. This example is a little bit funny in the sense that usually you aren't debugging your test, right? Here the test is actually wrong. But I was just trying to show you what happens if you return the wrong, you get the wrong thing out. Let me, sometimes you want a little more information, and you can add in an optional message that provides a little more when the test failure happens, it provides a little more information. So this is the failure message, right? So you see it when the test fails, and so it often has something like test failed for size of new dynamic array 2 object or something like that. And if I run it again, in the failure here, test failed for size of new dynamic array 2 object, and then it gives you the expected and that kind of thing. In some ways, it's a little bit redundant. Here we have the name of the method is sort of descriptive, test starting size, but it's nice to have a nice message that tells you a little bit more what's going on. A lot of times, you can if you were, for example, passing in an array of values, kind of like we do with our other tests, you could print out, say, I tried it with 1, 2, 3, and it failed, right? So sort of give a little more description of the test setup. There's nothing really here to set up, so I couldn't really describe it very easily. But this is really the main structure of a unit test, and you can do a couple. Let's write another test method. So usually when I do that, I'm going to copy from the last one just so I have the structure in place. Remember the add. Here I have the same name and the same parameters, so it's an error. I'm redefining it. So I'm going to give it a different name. Adding to size, and again I'm going to here have well, first of all let's put this back correct so it's what we expect. Okay, so here I have a new dynamic array, and I'm going to add one to it. da2 add David. Oops. And at this point, I would expect the size to be size 1. And here it's a test failed for data object with one, well, let's say with 1 string added, something like that. And if I run it now, passed all the tests. It says it ran 2 tests, 0 failures. And again, if my code were wrong, well, let's make it okay. So expect 1, and let's pretend size added added 1 to it for some reason, right? So now this one passed, this one failed, and again you get the error. Expected 1 but was 2, and it tells you where it happened. One thing to notice here is that it doesn't do these in order. The idea is that each test is independent of each other, and in some ways you don't want to set up things such that you depend on the last one happening correctly for the next one to work. So each one should be building something new and doing some stuff like this, and you shouldn't count on it happening first, the first one, and then the second one. There are ways to force it to go in certain orders, but you'll have to learn about that later. Okay, so if I run it now, hopefully it passes both. And you can actually put multiple certs in one test. Sometimes you want to add, they're all sort of related, and so it's okay to kind of check a few things. Here I'm doing some setup, and let's not waste the setup, and so I'm going to check that 1 and 2 both work, right? And it passes. So again, there's a little bit of a judgment to be made here about the granularity of the tests. So again, you don't want to have so much stuff being tested here, and if it fails here, it won't necessarily test the next one, so you lose some information. But if they are sort of in the same general idea, and in fact it's good to kind of not just test the first time, but test the second time as well, it's okay to kind of have a couple of these things all in one test method. Sometimes you'll find that the setup gets to be kind of complicated, and there are ways to write a little method that gets called before each one of these test things, and you can kind of create a little setup context. And there's also ways to kind of do some stuff after this stuff runs. But for now, again, it's enough to have a few asserts in here just checking some things. And hopefully you see the connection between this and the kind of testing you were doing in main for the earlier assignments, right, where you were building up some example and then seeing if the computation was correct. And again, the main difference here is that we actually check to see if they're the same, as opposed to just print them out and see what the result was. And the only thing that's maybe a little easy to get mixed up sometimes is that the assert equals, it's an expected value first, the computed value second, and then an optional failure message. And it would still check if those two were the same if you switched around expected and computing, but then the message saying expected this, got this would be backwards, and so it would be hard to read from a failure. It would be saying like the wrong thing. So make sure you're always doing it in this order: expected, computed, and then optional failure message. And I think you should write the optional failure messages. It just produces a little more nice information. If these are objects in here that you're comparing, it uses the dot equals to compare them. So like strings, for example, they don't have to be the same reference. They have to be the same set of characters. There are a lot of different asserts. For the most part, assert equals will be one that you use a lot. And if you just Google for JUnit5 Java assert, you'll get a big table of them. It's a little hard to read because it like has the same one: assert equals for int, assert equals for double, assert equals for float, assert equals for Boolean, and so there's sort of a lot of redundancy in this chart. But some things that are useful are assert true and assert false. And so if you have a method that returns true or false, you say assert true, you call the method, and then you have the failure message. So there's only one, you're not comparing two things, you're just saying I assert that the value of the expression in that first thing is going to be true, or assert false. So instead of saying assert equals true, call the method that returns true or false, and comparing if they're equal, you should just use that directly, assert true. You can also compare two arrays using assert array equals. So that's useful. You don't want to have to go through. You could loop through, have a loop, and then have the assert equals at each index value, and check each one at a time. But you can also assert array equals. You can assert null. So if you had a method that maybe returned a null for like a search that it didn't find anything, you could assert that you got null back from that thing. You can actually check exceptions. You can assert that it throws a certain exception if you call it a certain way. So you could, again, if you're testing like dynamic array, you could do a get with an index out of bounds and assert that it's going to throw the array index out of bounds exception. If you want to check for actual reference being the same, so instead of the dot equals, use equal equals, there's an assert same. And so, again, there's more than that, but those are, again, assert equals is going to cover 95% of what you want to do, and assert true and false, probably the other 4% of the other stuff, and maybe 1% of the time there's some funny thing you want to do. Actually, assert throws, if you're throwing exceptions, you probably want to check that quite a bit as well. Now, if you're comparing doubles, it's a little tricky because many of you run into this issue where the representational error, right, of doubles means that you can do a little bit of math and, for example, get 4.0 or 3.9999997, and you think from our own experience those should be the same values. Those are not exactly the same, and so there is a version, assert equals, expected, computed, and then some sort of delta or tolerance. And so typically you give some small number here, and it says as long as they're within that small difference, it's going to count the same as being equals. And so it will kind of prompt you for this. So it's not, it will say, hey, oops, you should, when comparing doubles, you should make sure to use this tolerance or delta value. All right. Now, what should be tested? You should test the same stuff you've been doing already. You should handle normal cases. If a method returns sort of multiple types of things, you should make sure you test each one of those types of things. And then you want to think what's called edge cases, and they're basically legal things, but they're somehow tricky, or where the code switches from handling one case to the other. That might be, for example, like a zero value coming in, or negative values, or an empty string, or a string with one value, something that is likely to trigger some slightly different behavior, and you want to make sure that those are being checked carefully. So in some ways, if you have a range of values and you check, oops, I hit that, and you check the beginning of the range, you check the end of the range, you check something in the middle, you're probably likely that the whole range is going to be kind of okay, right? But you want to check, you can't just check the beginning and the middle and hope that the last kind of value still works. There's also something called corner cases. So if you have multiple parameters coming into a method and maybe there's an interplay between those values, then you have to somehow think about, like, what if I do an edge case for the first parameter and an edge case for the second parameter? Those two edges make this corner thing. and that's like an extra special kind of case you should check. And so again, there's sort of this practice in thinking about how do I test these different values, and what you have to be kind of aware of how the code is working to make sure you're being careful with your tests. So lots of tests are good things, and they take a lot of effort, unfortunately. So it's sort of daunting, but they provide this sort of rigorous backdrop for your code that shows that it is performing as it's expected to perform, right? If you have any failed assert in a test method, it fails the whole thing. And again, you need to set it up so that correct code makes correct tests, right? You're not going to interpret like pass, fail, failed, pass, and it's like, oh, that's what I want it to be, right? You set it up so that everything should pass if the code is correct. And on a real project, what really happens is you're taking some chunk of code and modifying it, and then you check your changed code with a bunch of tests, right? So either you're adding to or already exists some test suite, and as long as it passes, then you can basically share your changed and tested code back with the team. But no one wants to look at it until it's gone through this testing process, and you can kind of show that it has some baseline of correctness. So these tests are like really the shared expectation of how the code should work. And when you're going around and messing around with the code to do something to it, you have to make sure you haven't broken either the code you're working on or somehow broken other code based on your changes. Now, this testing idea, again, is super important for checking that small chunks of code work, but it can get a little out of control. There's this nice story I read on a blog post about Oracle database. So Oracle, again, is a big, one of the biggest software companies in the world. They actually own Java now. They own a lot of stuff. Their core business is in databases. And this is from a developer who worked at Oracle, and it's like 25 million lines of C code. So it's one that kind of means it's straight C is sort of an older language. It's still used a lot, but people wouldn't necessarily start off development with C these days for a lot of stuff. But it's a huge and kind of old project. And 25 million lines of code is a lot of code, and it is hard for anyone to understand all those lines of code. So instead, what they do is they have millions of tests, and anytime you change something, you see some bug, you spend a lot of time trying to figure out all these like interplaying of things. There's all these little Boolean flags that say if it's like the first minute, whatever. It's very hard to understand these big if statements with 20 little flags in them and stuff like that. And then basically you hope you understand the issue enough that you make some change, and then you submit the change to this giant server farm that compiles the code, builds a new Oracle database, and runs millions and millions of tests. So while there's millions and millions of lines of code, they have millions and millions of tests that basically say, this is how this code is expected to behave. And even though they have this huge setup to run these tests, it still takes like a day to run all the tests. So you can imagine how painful that is. Like, you're working on your own code and you have a bug, and you go and, run the debugger and see what's going on. You add some print statements and run it a few times. You have an idea, you make a change, you run it again, you see how it changed, you make a change again, you run it again. You have this iterative process, right? And that process maybe, it's just 5 minutes in between changes or something like that. And so it's all in your head, and you can kind of be thinking about it. Here, the idea is you have to try something, you have to wait a whole day. You sort of forgotten it, maybe you had to move on to a different project in the meantime. You get some results back, maybe it passed, maybe it didn't. And if it didn't, then you sort of okay, I'll try this next thing, send it off, wait a day. Anyway, it sounds almost unbearable. In fact, that was sort of the point of this blog post, is that this real dependency on tests as opposed to making code that people can understand is a real problem for developers. All right, so unit tests are a fundamental part of development these days. You write code and you write tests. Those go hand in hand. There's hardly anywhere you're going to go where you're not expected to be writing some tests as you write your code. I do want to say there's an opposite style of development called test-driven development, or TDD, where you write a test. So basically you look at the specification, says, okay, this method is supposed to do this. So you write a test that says, okay, let's see if I make a first dynamic array that its size is 0. And then you go into dynamic array 2, and you write you look at the constructor, you write the constructor that says, let's start off with a size 0, and it passes the test, right? And then you say, okay, now I should have an add method that does this, and so you have to write an add method. You write a test that says, when I add David, is it size 1? And you write an add method and see if it works. So basically, you start by writing the tests, and then you write enough code to pass that test. Now, people like this because it forces you to think very carefully about what the code should be doing, and it forces you to write code tests that checks whether it does that. So anyway, it's an interesting style. Some people like it, and you'll probably run into that at some point. All right, now that the drilling and noises are going around me a little more strongly, I think it's time to wrap up, but we'll start using JUnit tests in our own code.